and get started with you. All right, so today we're going to be doing a Q3 science preview to get you ready for this next quarter coming up. But first, let's talk about some science announcements and updates. Our next virtual CCC meeting date will be March 16th for our grade level bands 3rd through 5th. They're going to be sent out via Teams, and it will be recorded and posted to your grade level, to your 4th grade science teams for later viewing if necessary, along with the PowerPoint of information that we share with you. Also, some more updates. CTLS, I know it says K2, that's a typo, I'm sorry about that, but 4th grade science workshop model unit lesson plans for Q3 for Q3 or 4 has been uploaded underneath the topic navigator tab in CTLS Teach. So you'll go to that unit topic, and then underneath instructional strategies, you will find some science workshop model lessons. Now, I am aware you guys are going to be trained on science workshop model on January 5th. So check those out after your training, and it will make a lot more sense to you the way we have it structured out. Also, updates for CTLS Teach, you will find the virtual field trip document has been uploaded to the course resources tab for you. So our Title I science coach, Kelly Bodner, got that together, and it is a working document, so you can add to it as well, but a great resource for you. And a little plug for our science department. If you have a cool science lesson or lab or investigation, or maybe you're doing a virtual science event in your classroom or at your school, invite us out to watch. We won't be able to join you in person, but we can connect with you virtually. So there's a link to that Microsoft form right there, and I've also posted it in your grade level science CCC teams as well. A couple of months ago, we would love to come watch you and highlight you. All right, so here's what we're going to jump into today. We're going to go over those Q3 science standards. I'm going to show you your unit plans and a phenomenon for each unit and some lesson resources that might not be in CTLS Teach, but I have saved everything that I'm presenting for you today in a OneDrive folder that will be shared to you right underneath the video recording of this preview in your Microsoft Teams. So at the end, we'll have time for questions and feedback. All right, so let's jump right in. Here is the 4th grade science teaching and learning framework that's located in CTLS Teach underneath the course navigator tab. It is what we use here in Cobb as a pacing guide or a framework to help guide your teaching. So today we're going to be going over weather and light, unit 5 and 6 in Q3. It is suggested that you spend about 5 weeks on weather and about 4 weeks on light. So what I like to do is download this document off of CTLS Teach and keep it handy for me when I'm doing my lesson plans and things like that, so I can jump right to the standards and I don't have to log on to CTLS Teach every single time. All right, so let's talk standards. All right, let's hit up weather first. Our weather standards, all of our GSE science standards start with the first 3 phrases, which is obtain, evaluate, and communicate information. Well, that's 4, but obtain, evaluate, and communicate are our science and engineering practices embedded within our standard. So you'll see that on every standard. And then we have elements that also, when we unpack these standards, these elements have the science and engineering practices embedded at the beginning of the element. So for Q3, we have obtain, evaluate, and communicate information to predict weather events and infer weather patterns using weather charts or maps and collected weather data. Element A, construct an explanation, is our science and engineering practice. So the students will construct an explanation of how weather instruments, specifically thermometers, rain gauges, barometers, wind vanes, and anemometers, are used in gathering weather data and making forecasts. Element B is interpreting data from weather maps. So they're looking at weather maps and they're analyzing and interpreting that data. including fronts, warm, cold, and stationary fronts, temperature, pressure, and precipitation to make an informed prediction about tomorrow's weather. So really that standard is asking students to look at a map that has all of those features and then make an informed prediction about tomorrow's weather. Element C, students are asking questions and using observations of cloud types, cirrus, stratus, and cumulus, and cloud data of weather conditions to predict weather events. So we're going to be going outside and looking at some clouds or pictures of clouds. And element D is constructing an explanation based on research to communicate the difference between weather and climate. So for this one, students are going to be constructing an explanation. How you have them present that to you is up to you. It could be written, it can be oral, it could be digitally, it can be however you want. But what the students are being asked to do is do an explanation based on research. So they're actually going to have to figure out what weather and climate is and communicate the difference between the two in their explanation. So some teacher background about weather. So you have to know a little something about something in order to teach these standards. So I'm here to help. So weather maps include a variety of information that's used to predict the weather, right? So a meteorologist gets the information needed to forecast the weather from both the lower and upper atmospheres, and they use weather balloons and radars and satellites in the upper atmosphere. And from the surface of the earth, a meteorologist can gather information from cloud cover, temperature, precipitation, dew point, air pressure, wind speed. Combining all of that data results in the formation of weather maps that we see on our news and our TVs every day. Information that's found on that weather map includes fronts, air pressure, temperature, wind speed, and forms of precipitation. So basically a front, when we hear a front, warm, cold, stationary, a front is a boundary between two different air masses, right? So that front, we have cold fronts, we have warm fronts, we have stationary fronts. We know basic background knowledge about temperature, pressure, and precipitation, right? So there are many different types of weather maps. So one map is a satellite map, which shows the cloud cover over a specific area. Radar maps are going to show our precipitation. Temperature maps going to show the high and low temperatures from a region. Wind maps, current wind maps is what they usually show, but it shows wind speed and direction. And current surface maps show fronts, precipitation, and the high and low pressure systems. And that's what we see on our news when our meteorologists and our news channels show us, or on the Weather Channel. So students should be familiar with a variety of maps and be able to discuss the current weather conditions in a specific location, along with predicting that weather that's headed for the location based on fronts, precipitation, and winds to the west of the city. That's what they're expected to do. So with clouds, that element C, clouds are also an indicator of the current weather conditions and the weather to come. So there's three main types of clouds: cirrus, cumulus, and stratus. Cirrus are those thin, wispy clouds. You might have heard your grandmother or somebody call it mare's tails. They're those high clouds. They're made up of ice crystals, and they can signal an upcoming storm or a weather change. Cumulus clouds are puffy, and they're the ones that look like cotton balls. They form kind of about 2,000 to 20,000 feet above the ground, and it usually means fair weather, but they can grow into large thunderheads known as cumulonimbus clouds. They kind of look like they get that anvil shape. And then the lowest clouds are the stratus clouds, and they form close to the ground as fog, or kind of up to about 6,500 feet above the ground. And they're low, flat, and gray, and often cover the sky. So those type of clouds, stratus clouds, they produce that drizzy, misty rain that's so annoying because it's like you can't turn on your windshield wipers, but then you have to because it keeps coming. So basically weather, for element D, weather is the current conditions at a given time, right? It's constantly changing from day to day, but climate, on the other hand, is the weather pattern expected for a region or a season. So climate is determined by collecting weather data over 30 or more years. So that's a big difference that students should know. Moving over to light. The standards for light during quarter three: obtain, evaluate, and communicate information about the nature of light and how light interacts with objects. So students, what's really cool about fourth grade is that these standards were first introduced to your students in first grade. So we're spiraling back in fourth grade to dig a little bit deeper. So they learned about light in first grade and how you can manipulate light. So basically the nature of light. So for these elements, element A is plan and carry out investigations. So they're actually going to do hands-on science to observe and record how light interacts with various material to classify them as opaque, transparent, or translucent. So this one's going to be a fun one to get students, science in the hands of the students, doing investigations to see how light interacts with materials. B, you're also doing some more experimentation, plan and carry out an investigation on the path light travels from a light source to a mirror and how it's reflected by the mirror and how it is reflected by the mirror using different angles. So super fun, hands-on engaging stuff to do. And then element C is plan and carry out an investigation. So we got 3 things that we have to do hands-on things for light. Plan and carry out an investigation utilizing everyday materials to explore examples of refraction. And I'm going to share a really cool activity that you can do for refraction and reflection in just a minute. And then we do have another standard for light that integrates sound as well that you can actually do in this unit or with your sound unit, but it's obtain, evaluate, and communicate information about how sound is produced and changed, and how sound and or light can be used to communicate. So we're really integrating sound and light together to do the element, which is design and construct a device to communicate across a distance using light and or sound. So for light, just some teacher background information. We know light is a source of energy, right? Our primary source of light is the sun. The light of an electric light bulb, though, is produced from a tiny, hot, glowing wire. So when you look at things, what you're actually seeing is light bouncing off of objects, and that's reflection. So reflection involves 2 rays, an incoming ray and an outgoing ray. And you can find some visuals to kind of visualize that yourself. But really what your students need to know and what you need to be able to know to teach this is that light travels in a straight line, right? When light strikes an object, it's either reflected, absorbed, or passes through it. So objects are described as being transparent when lights pass through them, and they're translucent when it allows some light to pass through it, but not all. Okay, it scatters some. Think of a plastic milk carton. Objects that absorb all light or block light are called opaque. And then when you can even, I want you to think about light's colors. So light's colors are part of visible sunlight, but unless you use a prism, kind of like the little, the picture I have above the standards, unless you use a prism, we only see the white light, right? So a prism is a 3-sided angled object that separates light passing through it into a visible color spectrum. Your red, orange, yellow, blue, green, blue, and violet. The reason this happens is that light travels at different speeds in different materials. So it's fast in air and slower in water or glass. And that has the effect of changing the direction of light or bending it and when it moves from one material to the other. And this bending of the light is called refraction. So we're going to give you an activity to demonstrate that for your students. So thinking about lenses and mirrors, because we have to do element B, right? So lenses and mirrors with curved surfaces bend or they refract light rays. But concave lenses have edges which are thicker than the center, so the light rays can spread inward, making things look a little bit smaller. So, and convex lenses have a thicker middle and a thinner edge, so the light bends outward, making things look larger. So concave makes things look smaller, convex makes things look larger. All right, so let's move on to some really good activities that you can do within your units and talk about phenomenon. All right, so each science unit that you do with your students, especially our science workshop model units, you need to have an authentic phenomenon to drive your instruction. So what you're going to do with that phenomenon, it can be a video clip, it can be a demonstration, it can be a photograph, It can be a picture in nature. It could be a nature walk, something that's occurring naturally in nature that makes students question and activate their background knowledge. So you're going to show them that phenomenon, and then students are going to write down questions and post them on a driving question board. On my visual to the right, you can see that once students generate those questions, they're going to engage in those science and engineering practices to answer the question about that phenomena, to figure out what's happening, okay? So you're going to make that anchor chart with them, and you're going to come back to that phenomenon each day in order for your students to remember what they learned the last day and to see if they can answer any of those questions. So let's talk about weather. So the anchoring phenomenon for this weather unit, I'm going to show you, it's called a rain microburst time lapse. I believe it's a YouTube, so it's only 30 seconds long. Of course, I have a little political ad. Here we go. But you're just going to show this to your students. No talking, just watching. Okay, so I've actually never seen a microburst in person, so that's really cool to me. But that microburst time-lapse video clip, you can watch the whole thing. It's only 15 seconds long or 30 seconds long. After viewing the video clip, the students will create questions about the phenomenon. You can have them write them down on sticky notes if you'd like. Your remote learners, you can do this with shared synchronous instruction. Your remote learners can write it on a digital whiteboard or a sheet of paper that they have. I've even seen some science teachers pull up a Word document in OneNote, and their remote students could fill out their questions there. You even have some guiding questions that you can use, like what's happening in this video? How does it happen? Can we predict when this will happen again? To really have them extending their thinking a little bit and thinking about how we can figure out what is going on. And you're scaffolding their questioning with that. So here for you, I have some snippets, some little pictures of activities that I have pulled for you from a book called Ames, Ames Science book that's all hands-on science activities. And the first one is called Fronting the Weather. With this activity, you're going to, the key question is, how can we use weather patterns we observe on a map to make predictions? So in this activity, they're going to look at weather patterns based on weather maps from 5 consecutive days. And then they're going to record the weather conditions at 12 locations on a map and make predictions. If you can see that Fronting the Weather data sheet over here, right here, this is where they're going to, they have locations and they're going to record the data for 5 days. They're going to make predictions for that location based on the day before. And then they're going to compare their predictions to the actual weather at each location. With this activity comes little mini books that you see here. One's called Fronting the Weather, one's called Movement of Air Masses. There's one called Precipitation Forecasting. Excuse me. Temperature, movement of air masses, fronts, and pressure systems. So if you're going to put this in a science workshop model work session station, really hard to say all at one time, you can have the mini books at one center, one station, and then you can have the weather maps with some devices for them to look up on another station, and then you could have the data sheet at another station. So you could really make this a really large scale activity using multiple stations to do this. And you would be sitting at one of these stations to help them. So you're collecting 5 consecutive weather maps or pages from your local newspaper or a series of maps that show a weather system moving across the country from west to east. Winter maps often show the greatest changes as the front passes through. So you want them to be able to see that change. We just had one recently. So that's a really, really, really good activity to do with them. That's going to be hitting up all of your standard elements for weather with this one activity. Here's another one called Out Front. I love this one because you can do a demonstration at the beginning of this activity. You can see down here, I have a photo of a warm, cold air mass cup model. So what you do is, let me make sure I get it right. I want to say the right thing. Okay, so you're going to use water to learn about weather fronts. So you're going to provide students with the definition that a weather front is a boundary between two air masses, so one hot and one cold. You're going to give each group approximately probably about like 600 milliliters of cold water in a liter cup or an 8-ounce cup or something like that. And then you're going to get a plastic bag and have, you're going to place a drop of red food coloring in the bag and then add probably about 6 ounces of hot tap water and seal that bag, right? So they're going to place the plastic bag of hot water on top of the cold water. You can see them doing it right there in the picture. And then you're going to carefully snip one corner of the bag so that the hot water can leak into the cold water, and make sure, you know, not to, you remind your students not to disturb the cup at all. Don't touch it. You just want to snip that corner. And you just want them to observe what happens and what should happen, you know, on a great day when science is doing what we need it to do. The water, the hot red water should stay on top of the blue cold water. And there's a distinct layering of the two temperatures of the water. And so this is serving as a model to help them think about weather fronts, right? You're reminding them that a front is a boundary between two air masses that have different temperatures. So to go with that, there's a little page where they can demonstrate, or they can sketch out their observation and what they saw. And then you move into the actual activity of how they can, weather fronts can be used to predict weather, right? So we are going to observe these fronts on these weather maps. So they already have created weather maps for you, as you can see here. This does come with a little mini book that you can put in a station that gives them more information about cold air masses, cold fronts, and warm air masses, and what happens when those two things mix together, and what it looks like on a weather map. But these out front weather maps, as you can see, there's a color key. It has high, low pressure. It has the fronts. So cold fronts are going to be in blue, and those warm fronts are going to be in red. And the little mini book gives students information on which symbol represents what. So it says color in the fronts, label the air masses, cold air or warm air, and then optional, they can draw arrows to show the wind direction based on where the front and how the fronts are moving. So what our students need to know is those dark lines that have the triangles, that would be our cold fronts, and the warm fronts are going to be those red semicircles, right? All right, so that is one really, really good one. And it also gives you a blank one for students to create based on looking at a national weather map or conditions from the Weather Channel or something like that. So you can really add in that data analyzation piece to this activity. So that's a whole week's worth of stuff right there. If you really wanted to drag that out all week and have a different station for every day with that warm, cold air mass cup model, that would be great and really engaging for your students. All right, so let's talk about light. Here is a great phenomenon for light, a funhouse mirror. So look at that little picture I have over there, that photograph. You have one mirror that's stretching out that little boy's legs, and you have another mirror that's shrinking that little girl's legs. Remember, I just told you about convex and concave lenses, but you're going to show that photograph for 30 seconds. They will come up with those questions that they have. Some guiding questions to scaffold your students could be compare and contrast the two images. What's similar? What's different? How can the mirror make you appear shorter, taller, thicker, or skinnier? And just have them start thinking about that. A really cool activity, if you have some prisms, maybe in a science lab closet, or you have a STEM lab teacher, or you just have some prisms because you taught 4th grade science for a really long time. Here is a really good activity that you can do. With this activity, you will need prisms, but we're basically just observing what happens. So the key question for this activity is, what can we observe when we look at light that is passed through a prism? And then that way they're looking at lights in their classroom and sunlight as they pass through the prism. So they're going to, it gives them information about what white light is made of colors mixed together, and prisms refract or bend the light and show us the colors it contains. And then they're going to color to match what they observe. Okay. And then a really cool one to hit that second element, that element on bouncing a light off of a mirror and at different angles. This one's called a reflection challenge, redirecting a beam of light. The objective for this activity, you're going to need some flashlights, a mirror, and it looks like some books and a cup. And all they're going to be doing is positioning the mirror so that the light beam from the flashlight hits the cup. So that's the objective. And it gives them different scenarios to try using a different amount of mirrors. Okay, so you're going to need 3 mirrors tops, and it tells you how to angle it, and you're trying to see if you can make it work. It's telling you how to do it, and then the students are challenged to figure out if they can get their flashlight to hit that cup. All right, so that's another really good activity. One that I want to show you that I don't think I got up in here. Oh, here we go. Yeah. Okay, another amazing activity for light is what's blocking the light. And this is going to hit that first element for you, where you plan and carry out an investigation to see how light travels through different materials, transparent, translucent, and opaque. So the key question for this activity is, how does light interact with objects? So you're going to need some transparent materials, translucent materials, opaque materials. You're going to write about what you observe. So they're going to define it on these papers and their own words, and then they're going to draw what they observe once they shine their light through that. So you're going to need flashlights for this one for sure. Or if you have laser pointers, that's okay, but please make sure safety concerns are always number one. And we were talking about safety with those if we use it. And then this last one I'm obsessed with because it's going to hit that third element with you, which is reflection and refraction. But you're experimenting with refraction with these. So it tells you what to do. So we're going to, for the first one, like arrows. So you're going to get a sheet of paper with arrows on it. They can use Sharpie, crayons, markers, whatever you want. You're going to lower the piece of paper behind the glass of water. What happened? And they're going to draw what happened, right? They're going to do that with arrows. With the sticker, they're going to place that empty cup on top of the sticker, pour water slowly into the empty cup, and then draw what happened. And then for a pencil, you're going to put the pencil in the cup of water, then switch the pencil for a spoon. Now try your finger. What did you do? Like, what happened, right? And so then we need to have them explain what refraction is based on their observations. And then they can draw an example that they see in the room. So other than that, that is all I have to share with you today. I'm going to stop sharing my screen. All right, that's all I have to share with you today. If you have any questions, please reach out to me in the science department at Alana Davis at cobbk12.org. And remember, this is all of these really cool activities and resources will be dropped into your Microsoft Teams after this presentation, along with the recording. And I hope you have a fabulous rest of your